So yeah, delighted to be here. My name's Ben. I work for BGSS.
We're co-sponsoring the event today,
And Aberdeen is our most recent office expansion, so hence the reason we're here. It is still a little bit weird doing these sorts of things in person after 24 months of being sat behind the safety of a Zoom screen, so forgive me while I acclimatise. So today Chris and I are going to talk to you a little bit about the work that we're doing with Elexon. So we're helping to transform their central infrastructure and some of their key systems to facilitate market-wide half-hourly settlement in the UK. So my role at BGSS, I've been with the company about 2 years now, and I look after our energy, commodities and utilities industry, so managing the relationships with all those customers and establishing the ways in which BGSS might be able to support them and solve some of their problems. I'll leave
Chris to introduce himself in a little while.
when he comes up and talks to you about the interesting stuff. So who are BGSS? Anyone heard of BGSS before? Quick show of hands. Great, that's good news. There's a few, cool. So we're the UK's leading privately owned technology and engineering consultancy. So we've been around for almost 30 years now, but experienced sort of really rapid growth in the last 5 years in particular. So we're now around 2,500 employees, 26 global locations and over 100 engagements with clients across a number of industries, which we'll come on to in a moment. In terms of what we do, you can see there on the middle side, this isn't necessarily supposed to look like a French flag, by the way. We don't have a presence in France. It just so happens to be the colour scheme we've chosen.
So 9
sort of services that are all underpinned by digital transformation. So everything from traditional sort of software engineering and DevOps through to data and AI and design and strategy as well. Across a variety of industries. So, as I said, my role is responsible for the energy, commodities and utilities sector, of which we kind of segment it into 3. So oil and gas, where we're supporting the likes of BP and Shell, energy and commodities trading with companies like Glencore and Gunvor, and then energy retail and utilities, so EDF, E.ON, OVO Energy and Yorkshire Water. But we've also got financial services, public sector, transport, betting and gaming, health and social care and retail and consumer markets. Again, here's our location.
So Scotland, we've had Edinburgh and Glasgow for a little
while. Aberdeen is the most recent of those. So I think I've now got sort of just reason to come to Scotland and convince my other half that it's not just to play golf. We'll see how that goes. And yeah, we've also got a presence in Europe. Copenhagen's our most recent office, but also Dublin, Lisbon and Porto. USA, we've got Houston and New York, and Houston obviously is a big hub for the work that we do in energy and commodities trading and oil and gas, and Melbourne in Australia. So getting into things then, has anybody heard of Elexon before or aware of what? Great, one. I didn't think there'd be many. They're probably the sort of, I was supposed to say best kept secrets, perhaps. They are responsible, play a fundamental role in the
energy industry. So they're responsible for the balancing
the settlement code of the energy industry. So what does that mean? Ultimately, they compare the amount of electricity that generators say they'll produce, compare that with how much electricity suppliers will be consumed, and then transfer the funds to the various different parties as appropriate. A few key facts just to demonstrate the sort of scale of Elexon in the organisation and what they do. So they're across the entire Great Britain energy market, handle at the moment more than 1.5 metre readings a day, although we expect as smart meter rollout continues, that will kind of continue to grow. Settle 46 terawatt hours of electricity annually, and handle billions of pounds of their of companies' money each year.
It's slightly acronym central today.
For that, I apologise. So MHHS, which isn't the most friendly to say, market-wide half-hourly settlements, is an industry-first programme championed by Ofgem, and is a first in so much as they've placed the responsibility for delivery of this programme on Elexon. So Elexon are what's known as the SRO for the programme. Ultimately, market half-hourly settlements will allow for a faster, far more accurate settlements process across the market for all market participants, seeing the introduction of site-specific reconciliation on a half-hourly basis. I think there's a couple of key things here to mention about the programme. One is, obviously this is a very positive benefit given everything that's happening at the moment. It's estimated to save $4.5 billion over the next
20 years for consumers. Great.
But also it's kind of the catalyst for a lot more innovation and change within the industry. So it's putting in certain market conditions which will facilitate things like demand-side load management and enabling a more intelligent energy system ultimately across the market. So instead of a spiked electricity demand, it will help to flatten the curve and provide a much more efficient process for electricity generators. And it's been seen as the first kind of step in defining what that blueprint for future innovation across the market might look like. So what is our role? So the Helix program is the name of the program, which is fundamentally transforming what
Elexon's central infrastructure in their systems.
So BGSS are responsible for delivering the first kind of portion of that, which is the data hub. My colleague Chris will talk about that in a moment's time, but we're also providing support to Elexon's program leadership team and the rest of the program. So you can see there we're working alongside CGI and Cognizant, but BGSS have been asked to provide sort of agile delivery expertise to the wider program. Elexon will probably be the first to admit they're not the most agile organisation in the world. It's been very waterfall. I don't think that's unique to large organisations in the industry. But yeah, we're helping to sort of upskill their in-house team as well with agile best practice. Again, it is a multi-supplier delivery, and we're also working very closely with Microsoft. So
this presentation today
will focus primarily on Microsoft, actually, but we've also got relationships, as you can see here, with AWS and GCP as well. But we're working very closely with them to ensure that we're leveraging the best possible Azure technologies to maximise value for the programme. So Chris and the team are working very closely with their solution architects and various other people. But the data hub is crucial to the rest of the project because the data that we provide to the rest of the program is fundamental to the smooth running of that and making sure that the settlements are accurate and provided at the right times. So that's it from me. I'm going to let Chris talk about the far more interesting stuff now, but just wanted to share a bit of context on who we are and the program as a whole as well. So I'll hand over to Chris.
Awesome. Thanks very much, Ben. So, hi everybody, I'm Chris. I'm a technical architect at BGSS. I also lead the architecture capability, our architecture practice in the central region. I'm going to talk a little bit today about what we're actually building at Elexon. There's a lot of stuff to go through, and I only have 20 minutes, so I'm going to go really fast, for which I apologise. If you want to know more about the details, then please come and find me. We're in the exhibitors hall. I'll be kind of hanging around afterwards. So I love to talk about this stuff. Come and bother me later on if you want the gory details. So what are we creating for Elexon then? Fundamentally, Helix is a data pipeline. We pull in data from four sources. We pull in metering data, so that's both smart meter and non-smart meter data. We pull in contract information, so the contracts that suppliers have with generators to buy power. We pull in the balancing costs from National Grid, so those are the costs that National Grid incurred when, kind of minute by minute, they need to buy additional power to keep the network stable. And we pull in standing data, so industry reference data, which is managed kind of industry-wide across the electricity supply and generation infrastructure. We pull this into the Helix system and take it through basically three sets of calculations. The first thing we do is called load shaping, where we take a particular type of power consumer, so I don't know, small domestic properties in southwest England, let's say, take a day's worth of data for them, slice it into half hours and work out what was the average consumption for each half hour throughout the day for that type of consumer. That gives us a curve that you've probably seen. It spikes up at breakfast time, drops down again, spikes up at lunchtime, drops down again, spikes up at dinner time, and then kind of stays high and eventually drops off through the night. What we can do with that is feed that back into the metering systems and use that curve to fill in the blanks. So for all of the meters that haven't yet moved over to smart metering, where we can't get half hour by half hour data, we can use the smart meter generated load shapes to estimate what the consumption was. And one of the drivers for doing this project right now is that we now have enough penetration of smart meters throughout the UK for those estimates to be representative. So we can actually use those estimated values for the whole of the UK to compute the balancing costs. So having got our half hour by half hour values for how much every single consumer of power in the UK has used, we can then look property by property or meter by meter and say which supplier is supplying this meter, okay, add this meter's usage onto their total. That allows us to work out each supplier's share of the amount of generation that took place for each half hour throughout the day, which then gives us a basis to allocate the balancing costs. So we make sure that the balancing costs are fairly allocated. A supplier who didn't use much energy doesn't have to pay more. A supplier who actually predicted they were going to use a large amount of energy and did use a large amount of energy doesn't have to pay more. So that allows us to do a kind of fair allocation of balancing costs across all of the suppliers. And having come up with those costs, we then circulate those back out to the industry, so the suppliers get them, the National Grid get them. There's then a process of approving those settlement costs, and money gets transferred, and the process goes on. So we do 3 calculations, take in 4 bits of data. That doesn't sound very hard. What makes this difficult? So there's a few challenges. The first thing is the way that metadata arrives at Elexon. Smart meter data arrives individually. So we get, if each meter sends us or we receive for each meter a separate message every day containing 48 half-hourly readings. So that means that when we're at full scale and we've got either estimated or actual data for all of the meters across the UK, we're getting 30 million updates, 1.5 billion rows of data coming in a day. So that's not astronomical in Internet of Things systems, but it's not small, it's not trivial. You know, it's 1,000 transactions a second every single second, and it's not evenly distributed either. So it's a non-trivial ingestion pipeline. The whole working set of data, so we have to maintain about 7 years worth of data for the process. That gives us a working set of about 10 terabytes. So again, not out of this world, but big. Big enough that if you were putting this into a traditional SQL database, things get complicated. It's doable, but it's hard work. We're into kind of big data territory here. The second issue that we have is these big numbers don't happen on day one. When we switch the system on, our scale will be significantly lower, and actually it will take almost 10 years before we get up to this scale. We don't want to be commissioning and funding a system which has this level of capacity for the whole of that 10-year ramp-up period. We need a cost model that scales as the system grows. The third issue we have is that the MHHS program is very much still in flight. Interfaces are still being defined, data flows are being defined. Things that we think are true today will not be true by the time we go live. So this has to be a system which is capable of being changed. It can't just be something that we deliver, go live with, set it in stone and walk away. This will continue to evolve throughout its life cycle. And the final issue is that all of the metering data that we collect is personally identifiable information. So all of the data that we're holding has to be held in a way which is compliant with DPA and GDPR and all that good stuff. So that sounds difficult. Luckily, there are a few things we don't have to solve. Things that we are not doing as part of this program, although these are all things we're not doing right now, but that we may have to consider in the future. So we have pathways to support all of these things, but we're not actually rolling out support for it as part of Helix. We're not doing exploratory data science. So we don't have data scientists kind of logging on, running queries, running notebooks, running ML models and things like that, and investigating the data. This is a lights-out, batch-based system that just runs in the background, generates the numbers, and sends them on to whoever needs them. There will come a time when we need to support this, but this is not that time. Second thing we don't need to care about yet is unpredictable scale. Helix will never go viral on Twitter and suddenly have a 100-fold increase in load. Our load is bounded by the number of properties in the UK. You know, we'll never get more meter readings than there are meters. And changes to the way that meter readings are gathered. So, for example, there is a suggestion that one day we might change from half-hourly to quarter-hourly. Those kinds of changes are agreed industry-wide, and they take years to come into fruition. So any changes to our scale requirements will come with a very long runway. We don't need to be able to scale up at a moment's notice, which is nice. Third thing that we don't have to worry about is data sprawl. Lots and lots of data platforms have this problem where they get dozens and dozens of different data sets in, and suddenly you've got 3 different sets of customer data and nobody knows which one's got the right address in it. And you have to start dealing with kind of metadata management and trying to track the lineage of data sets and things like that. We have a very small set of data, very well understood data types, and very well constrained and controlled. So we don't need to deal with that yet. And finally, data quality. This is a really nice problem not to have. All of our data providers, our upstream systems, are already validating data for us and giving us data that has been cleansed and processed. So whilst we have to be able to cope at a system level with the possibility that we get a feed full of invalid data, we don't have to build in the capability for doing sort of manual data cleansing and processing and things like that. Cool. So that's a little bit of kind of the scope. There are some technology constraints that we have to work within. So Alexon, our Microsoft partner, they are very much committed to Azure, and so we are building this on the Azure platform. Like most or many large organizations, Alexon very much favor not writing any code that they can possibly avoid. So wherever there are platform as a service or software as a service solutions that we can make use of, we are strongly encouraged to make use of those and not to just start building our own stuff. Thirdly, the way that the market-wide half-hourly program is structured means that separate components within the Helix system may at some point in the future be pulled out of the system and managed or developed separately by other organizations. So there are certain points in the system where we have to have hard boundaries and say, actually, even though technically it would make sense to just make this thing be a part of that thing, we can't do that from a management point of view because one day we might have to have these two things be completely separate from each other. So I wanted to just say a couple of very brief words on kind of the big data landscape as we see it at the moment. And it's very much a landscape right now of open tooling running on proprietary runtimes. So principal amongst that is Spark for data processing. So Spark is a framework that allows you to write logic for processing very large volumes of data and have that code run on clusters of machines in a way that minimizes the amount of transfer of data between those machines. That's a really hard problem if you have to do it yourself. So it's great not to have to care about that and to have somebody else worrying about it for you. Spark is a completely open standard. It supports a number of different programming paradigms and a number of different language implementations. So it's a great platform to start building data-based applications on top of. Where vendors are able to differentiate is in the platforms they provide that will run Spark-based solutions for you. So all cloud vendors and many non-cloud vendors have Spark platforms, each of which has different advantages and disadvantages. I'll talk a little bit about the Azure offerings in a moment. And the great thing about Spark is that whilst it's not write once, run anywhere, you can take Spark code that was written for one platform and re-platform it. And we have a number of projects at the moment where we are doing exactly that, taking code that's been written using the Spark framework in one runtime and re-platforming it onto a different runtime because it turns out that this new runtime has some advantages that the other one didn't support. So that covers the kind of processing side of things. And then on the storage side, again, we have open standards. So storage formats like Parquet, Delta, Avro, Awk. What this allows you to do is to store your big data in a way which is efficient for querying, but which is not locked into any particular tool. So if I have terabytes and terabytes of data in Parquet format, there are 30 different tools that I can then connect to that. I might be using Databricks to write it, but Synapse to read it. I might be using any number of. Might then want to move it to a different cloud and use Snowflake to read it with. What I don't have to do when I go through that process is what you may have enjoyed in the good old days where you wanted to move data from one relational database to another, and you have to go through some sort of torturous export and import process to get it out of your SQL Server and into your Oracle database. With these open standards, all you need to do is point the new system at the old data files, and away you go. There's no import and export required. So this kind of move to open standards for both the processing and the storage gives you huge amounts of flexibility that wasn't there in the olden days. So what does this look like in Azure? So the biggest problem that we have with data processing in Azure is the range of technology that's available. As architects, we're often we're like kids in a sweet shop. It's like, oh, I'll have one of those, two of those, three of those, and one of those, please. And suddenly your architecture diagram doesn't fit on a sheet of A1 anymore, and nobody knows what's going on. The hardest thing is just to choose which of the products you're going to use. So assuming you've got a big data shaped problem, for storage, Azure gives you Azure Data Lake Storage, which takes advantage of all the sort of underlying Azure storage capabilities. So the transparent replication across multiple recovery zones and multiple regions, snapshotting, the ability to tune the performance of your storage on the fly and say, whether you want to pay more for faster storage or pay less for cheaper storage. All that stuff you get kind of built in. For data ingestion, if you're connecting with other systems, then Azure Data Factory is the kind of Swiss Army knife tool. It connects anything to anything else. If you've got legacy systems to integrate with, then pulling files off some weird SFTP share and reformatting them from some strange delimited format that was last used in 1986, and then turning it into something which is actually modern and industry standard. Data Factory will do that in a kind of, I was going to say no code, but it's low code. It's mostly configuration. If what you need to do is large-scale streaming, then event hubs allow you to kind of offer a streaming ingestion which will scale up and down elastically. So if you're not receiving any messages, you don't pay anything. If you're receiving 1 million messages, event hubs will scale up to absorb that, queue the data, and allow you to process it at your leisure. For processing, assuming you're using Spark, you have numerous options. So tools like Databricks or Synapse give you a kind of very broad, flexible platform where you can make it do more or less anything you want to. And then there are tools like Stream Analytics or Data Factory Spark, where Spark is available to you, but in a much more focused way. So Stream Analytics is purely for consuming data off an event hub, transforming it around a little bit, and then pushing it onto somewhere else. It does one job, does it really well, uses Spark to do it. If you write your code to run in Stream Analytics, then later on you realize that actually that's too constrained, you just move it into Databricks and carry on from where you left off. So in terms of strategies for dealing with all this choice, I think you have to proof of concept, you have to pilot, because you've got to try these things out to understand where the limitations are, where the flexibility comes in, whether you need the flexibility or whether actually your problem is shaped exactly like one of these kind of focused tools. So proof of concept them, pick one, but don't panic because you can change. If your code is using Spark, you can re-platform it if you need to. So what have we actually built, or what are we actually building for Helix? At the core of our infrastructure is, how am I doing for time? Nearly there.
3 or 4 minutes.
Yeah. So at the core of our infrastructure is a Databricks platform running Spark, and that sits on top of an Azure Data Lake storage capability. We're ingesting the 30 million plus events a day from upstream services through an event hub queue. We're also integrating with a number of Alexon legacy systems using Data Factory to pull in data from those systems. And Data Factory will integrate both with the Event Hub for sort of real-time updates, but it can also just push batch-based updates straight into the data lake. We have a Salesforce implementation. I mentioned right at the start about the industry reference data, the standing data. The workflow for managing changes and approvals to that is torturous. It involves approvals going around the entire energy industry where they're voted and vetoed on, and then a month later updates get produced. That is all managed within Salesforce for us, and because Event Hubs offer a nice generic HTTP interface, we can just get Salesforce to integrate directly with that. There's no need for kind of additional glue in between the two of them. So we pull all this data into Databricks, and we then run a number of Spark pipelines to transform it, reshape it, get it into a structure that can be used by the calculations engines. Those are written in .NET. They run on Kubernetes. They pull data out of the data platform, do the calculations, push the data back in, and then finally we feed the results back downstream to MHHS. So where are we up to now? Where are we going next? In terms of Helix, we are about 4 months into the project, of which the first 3 months were kind of design, discovery, architecture, pathfinding. So we're really a month into actually writing code. There's a 12-month-ish process to get to a code complete state. We then have to wait for the rest of the program to catch up with us. MHHS is industry-wide, so suppliers, generators, the grid, the other market participants are all building their own systems that will integrate with this. Once they are ready, we have a 12-month phase of sort of industry-wide testing where we'll integrate all of these systems together, find out if they actually work and if the interfaces have been designed as well as we hope they have. And then we go live. How hard can it be? Meanwhile, back in Alexon, having done all this great work to put the data platform in place for this one specific targeted application, we're already looking to say, well, actually, couldn't we reuse this? You know, Alexon have many, many data-centric problems that they need to solve, and a platform like the one that we're putting in is very much reusable. So we have a bunch of other applications that we're looking at already. The principal additional requirement on top of what we need for Helix is the ability to do governance on top of that data. So once we start exposing data out to end users, allowing people to do analytics queries on top of it, things like that, we have to make sure that we're handling it securely, that we're giving the right people access to the right data, that people understand what the data is and where it's come from, and all of those other things. So we are looking at a governance platform to sit alongside the data platform and provide that kind of management layer. Cool. I think that's about all I have to say on the technical side. I'll hand back to Ben to finish off with 30 seconds to spare.
I'll try and keep this very brief, so I think we are literally about to be booted out. But a big thank you for coming along and listening to us today. The QR code in the middle will take you to a link to our driving digital innovation in the industry. We've also got some paper versions of that on our stand and some cool wireless chargers. There's our shameless plug to come and visit us. We're also doing a raffle, which will be drawn shortly. I don't know if there's any Rangers fans in, but if you fancy drowning your sorrows after yesterday evening, we're sponsoring the drinks reception at 3:10. If you're not a Rangers fan, you can celebrate. So yeah, a big thank you for listening to us today. And if you've got any questions, please come and visit us on the stand. Cool. Thank you very much.